Hello and welcome back. Today we are talking about prime factorization and the greatest common factor. So, first of all, what is a factor? Well, a factor is a number that is being multiplied. So, let's take the number 50. As we see here, we can just write down two numbers that can be multiplied to equal 50. A lot of times when you're doing your factor tree, you can put a multiplication sign in between the factors that you get if you want to. Okay, so 2 times 25 is 50, and 50 is divisible by both of those numbers with a remainder of 0. That's important. It divides in and there's nothing left over. Okay, so other factors of 50 are the number 1, because 1 times 50 is 50. The number 2, because 2 times 25, 5, because 5 times 10, and 10, because 5 times 10, and 25, because 2 times 25. Okay. So that was kind of a tongue twister. I hope I got them all. I got them all in there. Okay, so all of these numbers are factors of 50. A lot of times when you start your factor tree, you might begin with numbers that are different from somebody else's number. Like I could have put 5 times 10. But the thing is, when you keep going down, like this here would be 5 times 5. You keep going until you end up with nothing but prime numbers at the ends. At the ends here, nothing but prime numbers at the ends. Numbers that have no other factors besides 1 and itself. That's how far you keep going. And when you keep going and you get all of your prime factors at the bottom, you can multiply them together and they will equal 50. For example, 2 over here times 5 is 10. And that 10 times 5 is 50. So you should always be able to multiply them all together and get the original number, no matter what you start off with. We start off with 2 and 25 here, but yeah, you can put 1 over here and then put 50. And then over here you can do 2 little lines and break 50 down right here. You know, what matters is what you get in the end. It'll be the same thing in the end. Okay, so let's see what we have next here. It says all numbers are prime or composite. All numbers. They're either one or the other. So, what is a prime number? A prime number is a number who has factors that are the number 1 and itself. For example, the numbers 2, 3, 5, and 7 are all prime numbers. You can multiply 1 times 2, and that's about it. For number 3, you can multiply 1 times 3, and that's it. It doesn't break down into any other whole numbers other than 1 and itself. So what's a composite number? A composite number is a number that has more than 2 factors. So it will have the factors of 1 and itself plus a lot of other stuff. 8 has the factors 1, 2, 4, and 8. So, you have 1 times 8, you have 2 times 4, 4 times 2, 8 times 1, etc., etc., etc. The exceptions, or I'm calling them exceptions, but really it's just further information. And that information is that 0 and 1 are neither prime nor composite. They just don't fall into either one of those categories. Okay, so let's talk about how to do prime factorization. Method number 1, the factor tree. So if you're asked to find the prime factors of the number 60, here's an example of starting with the numbers 10 and 6. 60 is 10 times 6. But can you break either one of those numbers down further? Of course you can. 10, and let me move this up. 10 is 2 times 5. 6 is 2 times 3. Can you break any of those numbers down further? Absolutely not. These are all prime numbers. The only factors that these numbers at the bottom have are 1 and themselves. So we can simply write them out in a row on the bottom. 2 times 5 times 2 times 3. Because when you multiply them all together, you should end up with that original number. So one thing that you should get in the habit of doing, and it'll become clear later when we start turning these into exponents, is you should get into the habit of writing them in ascending order. Ascending or descending, doesn't matter. But for example, here's a 2 right here, and the other 2 is way over here. Well, put them side by side, and then move up to the next highest number, which is 3, and the next highest number, which is 5. When you have 3 2s, or 4 2s, or 5 2s, or whatever, you can use exponents to simplify writing down your final answer. So it's just good to get in the habit of combining them, not combining, but of putting the numbers in ascending order. Okay, we're gonna do another number quickly. We're going to find the prime factorization of 180. Okay, 180 is 18 times 10. Those are the numbers that we're going with right now. 18 is 6 times 3, and 10 is 2 times 5. Can you break those down any further? Well, some of them, or at least one of them. So the 6 over here looks like it can break down. 6 has factors in the numbers 2 and 3. 3 has no other factors other than 1 in itself, so you just move it down. 2 has no other factors other than 1 and itself, so you just move it down. And 5 has no other factors other than 1 and itself. Those were all prime numbers, these last 3, so you just move it down. And the answer that you're going to end up with is 2 times 3 times 3 times 2 times 5 equals 180. And these numbers that you've ended up with are the prime factors of 180. But we're not done yet. We're going to write them down in ascending order. So the order is going to change, and we're going to end up with 2 times 2 times 3 times 3 times 5 equals 180. And we're through with it. Okay, let's see what we have. Factoring negative integers. Okay, so negative integers, when you're factoring negative integers, what you're going to do is you're going to start off with the negative integer being the product of -1 and a whole number. So if you were factoring -10, then you'd be thinking in your head that the first thing you're going to write is that the factors are -1 and the whole number 10. Then you would take the composite number, which is going to be 10, and factor that 10 out. And you remember what we were saying before, a composite number is a number that has more than 2 factors. So usually that whole number, that other whole number that you're multiplying, is going to be the composite number. Let's see what these types of problems look like. So in factoring, that entire negative 120, the first step would be to express it as two factors. The second step would be to factor each composite number. So you can leave the negative ones as they are and just break down the second number. So negative 1 times 2 times 160 would be the next step. You're breaking the 120 down into 2 times 160. But can it be broken down any further? Yes, it can. So you just write that negative 1 down. You're not going to break that up. So you just write it down because it's a part of getting the answer to be a negative in the end. And you see if you can break that 60 down, and you can do that. Negative 1 times 2 times 2 times 30. Can you break that down any further? Yes, you can break down the 30 into 2 times 15. So let's see what we have. We have a negative 1 times 2 times 2 times 2 times 15. Can we factor any more from the composite number? Yes, 15 is 3 times 5. So we will end up with a negative 1 times 2 times 2 times 2 times 3 times 5. And since we have so many repeating 2's, it's important that we know that exponents can be used. So our final answer to the factorization of negative 120 will equal, okay, so we have negative 1 times 2 to the power of 3 times 3 times 5, or negative 1 times 2 cubed times 3 times 5. So, and you know what you should do when you watch videos like this? You should write down, pause the video periodically in between the work, in between what I'm doing, and pause the video and write this out and work it out yourself. Because if you just sit and watch a video passively, it's really not the same. So you have to get in there and write it for yourself, and write it in your own handwriting as I'm going along, because everybody has different handwriting, and you're more familiar with your own. Okay, so let's see what we have. We have common factor. Okay, so what we're going to do in the next video is we're going to get closer and closer to using this subject matter in polynomials, in factoring polynomials. We're going to do common factors. We're going to start talking about common factors and greatest common factors, and then we'll be ready to use this to factor polynomials. So stay tuned for the next video, and thank you for watching.